Okay, so today we're going to start a new lesson, but as usual, let's set the problem of the day first. I want you to read through it, make sure you answer the question, and we'll talk about it in class, next class. Make sure you pause the video to solve it. All right, so 1.4, we write formulas and equations. So we start off with a basic definition of what a formula is. A formula is an equation that relates two or more quantities, usually represented by variables. Some of our most common formulas, you should be somewhat familiar with them. Distance, we have the formula d equals RT, or distance equals rate times time. Write these down as we go. Temperature is another common one. Fahrenheit equals 9/5 degrees Celsius plus 32. Next couple are more math ones, I would say, than like maybe a science class or physics class. Area of a triangle, area equals 1/2 base times height. Area of a rectangle, area equals length times width. Perimeter of a rectangle, perimeter equals 2L plus 2W, or perimeter equals 2 times the length plus 2 times the width. Area of a trapezoid, a little more complicated one. Area equals 1/2 height times the quantity base 1 plus base 2. Area of a circle is pi times radius squared. I didn't put the symbol for pi, so I wrote it out, but it's pi times radius squared. And last but not least, circumference of a circle. Circumference equals 2 times pi times radius. I'm going to take a look at manipulating these formulas and rearrange them, because what if I'm not looking for distance? What if I'm the first one looking for rate? Or what if I want to, a really common one in real life, with temperature? What if I'm in another country like Canada and I have degrees Celsius, I could convert it to Fahrenheit, right? But what if I am over there and I know what Fahrenheit is, but what does it match up to Celsius? So there's a lot of different reasons as to why you want to manipulate or rearrange formulas. So the next definition is solve for a variable. We write an equation as an equivalent equation in which the variable is on only one side. So we have two examples with the formulas that we just talked about. So example 1, solve for the formula d equals RT for t. So in example 1, once again, what we're going to do is we take a look. We want to isolate the t by itself, right? So I need to think to myself, how do I get t long? It's rate times time. So the opposite operation of multiplication is division. So we're going to divide r from both sides. And my formula is going to be time, or t, equals distance over rate. So for example 2, let's take a look at this one. Solve for the formula, or look at the trapezoid formula. Area equals 1/2 height times the quantity b1 plus b2 for b2. All right, for the next one here, what we need to do is we need to get b2 long. But if we look at where b2 is in parentheses with the other b, b1. And I have 1/2 being times by h, being times by the base. So there's 3 parts going on. What I think is easiest first is to get rid of the number. Let's get rid of 1/2. The opposite of multiplying by 1/2 is multiplying by 2 over 1, or 2. So let's do that first. We'll do it in 2 parts. So these go away. Oh, hold on 1 second. Let me fix that actually. I wrote it wrong. I should have moved it over. Okay. So we'll do times 2 here. That was all right. Let me fix this. Then times 2 on the other side. So now if we take a look, 1/2 and 2 goes away on the right-hand side, and I have 2a here. All right. So I have 2a equals h times b1 plus b2. All right. So now, before we could isolate any of the b's, if we take a look here, we still have an h in front of multiplication. So the opposite operation is to divide by h to get rid of it. And what I'll have next is 2a over h equals, now I could drop the parentheses because we got rid of the 1/2 and the h already. So we could just write b1 plus b2. From there, we want to isolate the b2, so it's positive b1 plus b2. So let's move the b1 over to the right. It's a positive, becomes a negative, right? We're transposing. All right, so 2a over h stays there, minus b1 and equals b2. And if you want to rewrite it with b2 first, that's totally fine. But for this case, I'm just going to leave it as is. So here's our answer. 2a over h minus b1 equals b2. All right, so that's a little bit more of a complicated one. So we talked about, rearranging formulas, but what if I give you a word problem and we want to come up with a formula and rearrange it ourselves? Let's look at the next example here, example 3. It says a campus bookstore sells t-shirts for $15 each and sweatshirts for $22 each. A, write an equation for the bookstore's revenue R from selling M t-shirts and N sweatshirts. All right. So we need to come up with a formula first. We talked about revenue. So we're going to write R equals. We're going to take the number of t-shirts times $15 each. So 15, we're going to use the letter M. And we're going to add it to the cost per sweatshirt, which is $22 each, times N. Number of sweatshirts. All right. So that's part A. Part A says to write an equation. Now, what if we wanted to find the total number of t-shirts? Maybe we know our revenue, we know the number of sweatshirts. So let's rearrange it here. If you look up here, 15M plus 22N. We want to get M by itself, or 15M by itself. So let's take the 22N, which is positive, and transpose it to the left. It's negative 22N. So we have R minus 22N equals 15M. Now to further isolate the M by itself, it's 15 times M, so let's divide both sides by 15. And last but not least, I'm going to rewrite it one more time. M equals, and we don't have to simplify it again like I said before. Leave it as a big fraction for the formula, just like we've done the other ones. And here's my answer. So let me box this first. So we get the final answer is M equals R minus 22N over 15. Now, where's a more practical application of this? You did a lot in Algebra 1, and there was a purpose to it. If you go to the last set of problems, you found the equation of a line. When you graphed, you always graphed an equation in y equals mx plus b form. And maybe I gave you standard form, or maybe you learned standard form and said, okay, I want to graph my line. Let's get it in y equals, so I know what my y-intercept, my b is, and what my m, my slope is. Not that you can't graph in standard form, but usually we're trained to rewrite it in y equals. So look here, say I wanted to graph this, all right? We need it in y equals. So I have 5x plus 3y equals 8. We're going to solve for y. All right, so let's start by transposing the x over. We want to keep y by itself, right? So 3y equals, and then 5x goes over to the right, it's a negative 5x. Plus 8. 8 stays there, so it's just plus 8. Okay. Now, it's 3 times y. So what we have to do is divide both sides by 3. And I get y equals negative 5/3 x plus 8/3. Now you might be wondering, well, how can we split this fraction up into 2 parts when in the last couple of examples we didn't? Simple reason. Those are formulas. This is something if we graph a line, right? It's an equation of a line. So why I'm asking you to do it in this case is because if we graph this, we want to know negative 5/3 is my slope, it's my m. And the y-intercept or the b would be 8/3. So I'm going to ask you only to split them up and simplify them in this form when it's an equation of a line. Now, one more example, example 5. If we take a look to solve 2xy minus 5y equals 8 for y, this one's a little bit different because take a look. I have 1y and 2. Do you see that there? And here, how many did I have? I had only 1. Any other formula or equation we did so far only had 1 of that particular variable. So this one's a little more confusing to solve, and it's because there's 2 y's. You can't just say, all right, I'm going to transpose negative 5y over to the right, because you're still going to be left with the y on either side. This one we have to approach a little bit differently when there's 2 y's. Not 2 x's, but 2 y's. All right? Whatever variable you're looking for if there's 2. They both have a y in common, right? So let's start by factoring out that y. All right, that's what we're going to have to do in this case here. So if I factor out a y, I get y times the quantity, 2x minus 5 equals 8. Now I only have one y. I went from 2 down to 1. Y is being times by that quantity, so to get y by itself, I have to divide by the parenthesis, which is 2x minus 5. So let's do that to both sides. All right. Now, last but not least, we have y by itself. So here's how I'm going to write it, and I'll explain why. Keep the 8, so y equals 8 over 2x minus 5. You might be saying, well, how come in this one you didn't break up the fraction, but here you did? This one is not an equation of a line. There was 2 y's, so you could leave it as is. The only time I want you to split it up is if we were graphing like a line form. Okay, that's it for the lesson. I want you to pause here and complete the homework. We have 8 problems there. Read through each of them. Problem of the day for number 1, 2 and 3, we rearrange the formulas. Same with 4 and 5. We're looking for h, but there's a picture that translates with it as well. And then we're going to solve the equation for y on 6, 7, and 8.